Hey there, my name is Hazel Weekly, and I am really excited to be here as part of SLOconf 2023. Today I'll be talking about something I've been thinking about recently, which is it possible to motivate SLOs mathematically? Not necessarily in a rigorous fashion, but really more so in, is there really an explanation for them beyond just, this makes sense, and let's just do that? So I'm going to kind of dive right in and very roughly take you through my current train of thought and my current thought process. It's pretty in progress, so don't expect a lot of polish. But we'll see. Let's dig in. So I'm sure you probably have seen this diagram before of like the known knowns, unknown unknowns, and sort of like this grid of what you can know about a system. It's a really nice starting point, and this is kind of where I started. And one thing that does bug me about it though is it's not really a grid. It is kind of like this circular thing, and this is a spectrum, and this is a spectrum, and they all overlap. And there's this like, giant messy question mark in the middle. But that aside, we do have this, the known knowns. What do you know that you know? What do you know that you don't know? What's the difference than things you don't know that you know? And of course, the unknown unknowns. So I would say that known knowns are the ability to ask meaningful questions and get a useful answer. And so how does that tie into SLOs, and how does that tie into like your system? Well, so let's say you have what you think your code does, and you write something, you have it, let's ship it to production, and then you figure out what it actually does, and then you have this virtuous feedback loop of, are you shitting me? Why are you like this? Are you serious? Why are you like this? What the fuck? Why? Back and forth until your understanding of what it does and what it actually does is as close as possible. And so I think that up here we have SLIs. And down here we have observability. Cool. So, but if we have SLIs on the top, then it kind of feels like our known knowns, like the meaningful questions we can ask, are pretty much really only about the state of the system as measured. And so for me, realizing that we have this series of different states over time really gets me thinking about integrals, because I'm a nerd like that. But so if you have this ability to query something, query the state of the system, and you get an answer. Is this known unknowns thing, is that over the state of the system, as the state of the system changes, if you repeatedly query it and you test that against your actual understanding of the system and sort of validate, is this reasonable? Does it match my expectations? It's kind of like the known unknowns. And it feels like SLOs. So I feel like SLOs are here, and like maybe this is kind of what SLOs are. And I feel like this is observability. And so that leaves these last two. What kind of are they? So if this one is observability, and this one is SLOs, and we have this idea of like integrating twice, because in math, if you figure out, maybe I can do this, the first immediate thing you try and do is you just hit that hammer on every nail you can find. So I'm going to integrate it again. But in this time, instead of like, as the system changes, we have this concept of maybe the system kind of stays the same, but now you know when you're changing things. Maybe like fault injection. Maybe like, so that one felt to me like this is really, this feels like chaos engineering. It's this third one. So you have that observability, the SLOs, and the chaos testing. So now we're kind of getting somewhere. but unknown unknowns don't really fit anywhere because I only had the time and the state of the system, and I kind of ran out of things to modify. So the next step was thinking about what else is there. So at this point, I would like to mention the math is going to get completely unhinged. It will continue to get worse the entire time I'm talking, and do keep that in mind. However, this should be entertaining, hopefully. So, if I do these integrals, and I just mathematically, syntactically do them and write them out so that we can reference them later, we have this like, you know how unknown unknowns don't really fit? Well, so I'm going to put this little k in there and just integrate it anyway and see what happens. And so this k that I'm thinking of is like when you have a socio-technical system, you have a combination of the social aspects and technical ones. And so far in these first two stages, we've been integrating over changes in a technical fashion. You know, time and space, time and state, time and whatever. And so the only thing left is the social aspects. So K is like that knowledge that as you migrate through a system and as you start to understand it better, you have this sort of bouncing back and forth, trying to like understand it, trying to get that slack and actually think about it and figure out what the boundaries are and how you can inject humans into them more meaningfully. And of course, now we have these three, you know, one constant, two constant, three constants. And whenever I see a 1, 2, and 3 in there, and then like this little thingy of sort of a combination of all three, that immediately makes me turn my mind to Aspy's law of requisite variety. Because it feels like that, right? You know, understanding the system can only be related to like how well everything plays together. So we have this change of the system is the known unknowns, changing over time is the unknown knowns, and changing of the knowledge of the social aspect of your system be the unknown unknowns. And we have Aspy's law of requisite variety. I wrote that out of like, this is how it's typically written in literature. This is actually from Aspy's paper. And I picked this one because it has this. And this is going to be important. Most everyone else ignores this because they assume that like this thingy, like they assume you can zero this one out. I don't think you can for us. So let's see what we get there. If I take this giant like result of the integral from earlier and I shove it in there, it feels like we have this, the combination of everything. And like, you know, this is the SLOs because you have, so the entropy of essential variables as in everything you can do to the system, like your whole total knowledge of the system and everything that's essential for it. And then you have like that time, that knowledge, that constant of like the thing you need to solve. Entropy of the regulator for known disturbance. I mean, regulator of known disturbance, that's chaos testing. It just feels like chaos testing, right? It's gotta be. And and then we have the entropy in the regulator. And this was really cool for me, really cool. And the reason for that is because, so you have this optimizing slack thing. For when a system is going, you have that margin of error. And you can see it in some of the papers in resilience engineering, particularly the paper called Going Solid, of like, as you get better at manipulating the system and like thinking about it, you start to actually figure out how much margin of error can we get away with. And you say, let's have less margin of error because we think we can get away with it right now. Or maybe let's add more. And you start to put humans in the system more effectively. And that really feels like that. And so if you have these in there, it feels like SLOs are actually mathematically, so to speak, a natural consequence of wanting that next step of understanding a system in context and are in of themselves actually necessary for getting to the point where the organization can effectively manage itself and its relationship in the socio-technical system over time. Thanks. Hope that was helpful, useful, sort of maybe kind of almost correct. All right. Bye.